Good morning, children. How are you all? I hope you are fine. Today, in this section, we are going to see the next part in algebra. Okay. Today, we are going to discuss about the new topic, factorization. How to factorize the algebraic terms and algebraic expression. Okay. What's the factorization? Already we know that what is factorization. We did the factorization for numbers. Isn't it? We did the factorization for numbers. How we will do? You did in the first chapter. To find the square root of a given number, cube root of the given number, you used a method called prime factorization method. So the word factorization is not new for you. Here we are going to use the factorization for algebraic expressions. Okay. So prime factorization. What we will do in the prime factorization? Recall once what we will do. When a number is written as a product of only prime numbers, it is said to be prime factor form, and the factorization is called prime factorization. Any number, any composite number, if you express in the product of primes, it is called prime factorization. Okay. So the prime numbers cannot be further factorized. So that is the prime factorization. For just for the recall, if you take the number 36, 36 is a composite number. How will you find the prime factors? 36, if you start dividing by 2, 18 into 2 is 36. Again start dividing by 2, 9. 3 3s are 9. The remainder is 1. So 36 can be expressed as the product of primes as 2 into 3 into 3. Isn't it? That is 36 can be written as 2 square into 3 square. Like that we can express any number as a product of primes except 1. That is the root of prime factorization. Isn't it? Have you recalled that? Yeah. Now, in this section I told you, we are seeing the chapter algebra. In algebra, we are going to learn the factorization. So, we are going to factorize the algebraic expressions. Okay. So, first, each term of the algebraic expression is a product of its factor. Okay. Each term of the algebraic expression is a product of its factor. How? For example, if I am taking any algebraic term, 3xy square. 3xy square can be written in the form 3xy square can be written in the form of 3x into y square. See, the product of two terms. In other way, it can be written as 3x into y into y. 3 into x into y into y. Otherwise, 3 into x into y square. 3 into x into y square. So, this similar algebraic term can be expressed as a product of terms. Each term in this algebraic term is the factor for the given term. That one is given here. Each term of the algebraic expression is a product of its factor. Each term is always the product of its factors. So, see, we are having three ways to express the factors here. Observe the second way. What I expressed here, this is called as irreducible form. See here, this may be further reduced as y into y. Here also we can reduce to because the power y square. This is called irreducible form. How we are writing? For 36 we are writing the prime factors. The prime factors cannot be factorized more. Isn't it? A prime number cannot be factorized more. Because a prime number can be possible to divide by the same number only. Like that, for algebraic term also, if you are expressing in the irreducible form, we can't say here they are the prime numbers. So, in algebra, we are using the term irreducible. Okay. So, every algebraic terms and algebraic expression can be factorized as the irreducible form. Okay. So, remember that each term of the algebraic expression is a product of its factor. Okay, so based on this only, okay, we are going to factorize the algebraic expressions. To factorize the algebraic expression, according to the given expression, we can use the method. Okay, if only one single term is given, each term is the factor of the given expression. So if you split the term, directly we will get the factor of the given expression, isn't it? If we want to use the identity, by saying some expression, we can get the idea to use the identity. Are using the HCF, are using the splitting the term, grouping the term, we can factorize. So, based on these methods, we are going to see how to factorize the algebraic expressions now. Okay, so we'll solve the exercise problem now, how to factorize the algebraic expression. we are going to factorize the algebraic expression in different ways. Okay, just see the first problem. Write the irreducible factor of the expressions. We have to express this algebraic expression as irreducible factors. Irreducible factors means that factors, each factor cannot be factorized more. Okay, that condition we have to see here. See the first one, for x, y, z. Here we are having a number, arithmetic number 4. 4 is a composite number. So we are going to write here as an irreducible factor. That means that number should be expressed in the form of primes. Okay, how we will express 4 as in the form of prime? 4 can be expressed as 2 into 2. 2 and 2. Here the 2 number 2 is a prime number. So it is the irreducible form. So how to express this means 4 can be written as 2 into 2. And all other variables what we are having here are already, just if you write each term as a multiple, it will become as an irreducible form because they are having the power 1 only, once only. So see here, the irreducible form of 4xy z is 2 into 2 into x into y into z. We found all the factors of the given algebraic terms in the irreducible form. See the second subdivision, 3xy square into z plus 1 the whole cube. How to express this as a irreducible form? 3 is a number here. There we got 4. 4 is a composite number, so we change as a prime number. But what about 3? 3 is already a prime number, so it is in the irreducible form only. So just we can write 3 as 3 itself. Into x into y square. Y square can be expressed as y into y. Okay, y square can be expressed as y into y. Z plus 1 whole cube. So into z plus 1 into z plus 1 into z plus 1. Because any number x cube means the meaning is x into x into x. The factors of x cube irreducible form we can write like this. Okay, x into x into x. Likewise, here we are clearly asking the irreducible form. So we have to break the powers to form the irreducible form. So 3 cannot be expressed more as a prime number. So 3 into x into y can be, y square can be expressed as y into y. The factors of y square is y into y. Into, for the next term we are having z plus 1 the whole cube. So we are having 3 factors, irreducible factor for that. They are z plus 1, z plus 1, z plus 1. So totally for this given algebraic term, the irreducible form here. Okay. Now see the last one. Can you guess what will be the answer for the last subdivision here? We have to express as the irreducible form. A number 9. A number 9 is an irreducible form? No. 9 is not a prime number. So we have to convert as a factors of prime. How 9 can be expressed as a factors of prime? Yes, 3 into 3. So we can write 9 can be 3 into 3. P already in the form only. So P into Q. Q square, we have 2 terms of factor, that is Q into Q. The next term, P plus H into Q minus 5. We are at the power 1 only. This is considered as a single term. Okay, so we should not break that. P plus H or Q minus 5 is a single term. They are not having more factors for that. So we can write as it is. So the irreducible form of this is 3 into 3 into P into Q into Q, P plus 8 Q minus 5. Here, this is also a single term, but we are having the power Q. That means we have the factors for 3 variables. 3 factors are there. So we have expressed as z plus 1, z plus 1 and z plus 1. But here, P plus 8 Q minus 5, they are a single term with 1 factor only. So only we are writing the factor as same. Okay, yes. Now we are going to solve the second problem. Now in the second problem we are going to find the HCF of the following. Okay, HCF. What you know, for a given 2 numbers we have to find the HCF. We will use the prime factorization method and we will find the HCF of the given 2 numbers. Okay, so here also we are going to find the highest common factor. How to find it? We solved the first problem now. What we did means we expressed the algebraic terms as irreducible form. Here also we are going to use the technique. We are going to express the given terms here, whatever the given terms here in the irreducible form. From that we are going to identify the common factors. The common factors comes for the HCF. Okay, so first problem, here we are having 4x square. First we will take it 4. First term 4x square y cube z cube. I am taking the first term. What is the irreducible form for this? We are having a number 4. Number can be 4 can be expressed as the product of primes as 2 into 2. And for each every variable, we have to express the irreducible form. How to express the x square can be expressed as x into x. And y cube can be expressed as y into y. And z cube can be expressed as z into z. Isn't it? See, 4 we have expressed as 2 into 2 x square. So 2 times y cube 3 times and z cube 3 times. So this is the irreducible form of the first term. Now go for the second term. What we are having in the second term? 6xy z square. How to express this as the irreducible number? So product of primes as 3 into 2 or 2 into 3, whatever. The next is x into y into z square. So we are adding z for 2 times. What is HCF? Highest common factor. Now we are having the irreducible form of the given two expression, algebraic term. So we have to identify the common factors. See, what are the common factors here? We are having a 2, here also 2. Other than that, we are having 1x and round for 1x and y. So take 1y and 2z. So take any terms, algebraic terms here. So what are the common factors here? What we are having? So what are the common factors here? We are having 2, comma, what are the next? X, comma, y, comma, z, comma, z. These are the common factors. The common factors can be considered as the HCF for both. Common HCF for both. So HCF of the given terms. Finally we can write as 2 into x into y into z into z. Combine this as a product and write 2x y z square. 2x into y xy z for 2 times. So z into z is z square. So the HCF of the given two algebraic terms you can find directly by taking common outside also. But using as the first problem, we know how to write the given term in the form of irreducible form. If you write the irreducible form of the two terms, you can easily identify the common factors whatever the common factors of both forms will come as the HCF. So we finalize the HCF as 2xy z square. So let us try for the second problem now. What is here we are having the terms 15abc, 5a square b, 20abc cube. Here we are having 3 terms. We have to find the HCF for all these 3 terms. What we are going to do? Yes, we are going to express each term in the irreducible form. First term, what is the first term we are having? 15abc. 15 is a prime number? No, it is a composite number. How to express 15 as a product of prime? 15 can be expressed as a product of prime as 3 into 5. These are the two prime factors for 15. So 3 into 5. What about the other? We are having single variable points a into b into c. So the first term we expressed as irreducible form. How for the second one? What is the second one? 5a square b. We are having arithmetic number 5 here. 5, what is the form? What is the number 5 here? It is already a prime number. So we can take 5 as it is and a for a square here. So a into b. And what is the third term we are having? 20abc cube. 20. Arithmetic number is there now. How to express 20 as the product of primes? If you want, you can do the prime factorization of the number 20. Or if it is simple number, just you can express directly. How to express 20? 2 into 2 into 5. So if you are not able to do directly, just go for the prime factorization of the given number. So 20 means I can factorize using the first prime number 2. 10 2s are 20. Again by 2. 5 is a 10. 5 is a prime number. So on. So it can be expressed as 2 into 5. And into what are the variables? A with power 1 only. So it cannot be factorized more. So A into B also single variable. So B into C has the power 3. That means it has 3 factors. So C into C. Now we expressed all the 3 given algebraic terms as the irreducible form. To find the HCF, what we have to do? We have to identify the common factors. Okay. So what are the common factors here? See whether 2 is there? No. In the arithmetic number we are having 5 as the common factor in all the 3 terms. And go with A. We are having 1A common for all the terms. And B is also common for all the 3. Extra we have the term C, but C is not common for all the 3 terms, so it will not come as the common factor. So what are the common factors here? So what are the common factors here? We are identifying 5, other one is A, B. 5A, B. Therefore, the HCF of the given 3 terms is 5 into A into B. That can be written as 5AB. So, using this way, whatever the algebraic terms, 2 terms or 3 terms, whatever the algebraic terms it is given, just express the algebraic terms in the form of irreducible form. Then you can identify the common factors from the irreducible form and you can identify the HCF of the given terms. Okay. Now we are going to solve the third problem. Here also we are going to use the factorization only. Okay, we have to factorize using HCF. What we are going to do is we are going to use the technique what we need to find the HCF. We expressed the given terms as the irreducible form and we found that now here also we are going to factorize. Before that we are going to write the given terms in the irreducible form. Then we are going to identify the common terms, picking out by that we can get the factors of the given term, factor of this given expression. Okay. Now see here we are having 15xy plus 25xy y square. 15xy. How to write in the irreducible form? 5 into 3 into x into y. So we express the first term as 5 into 3 into x into y. In middle we are having plus, so plus of 25 can be expressed as, what is the irreducible form of 25? 5 into x square can be written as x into y square can be written as y into y. So for both the terms we have expressed as the irreducible form. 15xy as 5 into 3 into x into y, 25x square y square as 5 into x into y into y. Now, what is the work to factorize? How to factorize now after this is, first identify the common terms. Take the common terms outside from the 2 terms. What are the common terms we are having? 5 and x, y. If we take these 3 terms common outside, 5 into x into y. If we took the common terms outside. What are the remaining terms in the first term? Only 3. So we are having only 3 and middle we are having plus. From the second term what are the terms we took outside? 5x, y. So what are the remaining terms? 5x, y. One more 5 into x into y. So we express the given expression 15xy plus 25 x square y square. The product of this expression are, the factors of this expressions are 5 into xy, 3 plus 5xy. We expressed this as a factors. Okay, for this given expression, the factors are 5xy into 3 plus 5xy. Okay, now we'll do the second problem. 6a. Here also we are going to use the same method. 3 terms are there now. We are going to write the 3 terms in irreducible form. After writing in the irreducible form, we are going to take the common outside so that we can express the given algebraic expression as the factors. Okay, factors is Now 6n. Go with 6n. 6 can be written as 2 into 3 because 6 is a composite number. If we express as a prime number, 2 3s are 6 into n. So we finish the first term. In middle we are having plus. 12 can be expressed as 2 into 3. 2 2s are 4. 4 3s are 12 into n square. So n into n. So finish the second term. 12 is a composite number. 12 has more factors. 12 can be expressed as 6 2s are 12. 4 3s are 12. Likewise, we can give many factors for 12. But here we are writing the irreducible form. That means 12 should be expressed only in the form of primes. So what is the method? 2 into 3. 2 is a 4. 4 3s are 12. And what about the last term? Plus of 18. How 18 can be expressed as the product of primes? If you want, you can use your column 18. 2. 9 2s are 18. 3 3s are 9. So 3 is a prime number. So how to express 18? 2 into 3 into 3. 2 into 3 into 3. N cube. So how many factors for n cube? 3. So n into n. Shall we identify the common terms in all the 3? What are the common terms here? We are having 2 in all the 3. Also 3. Yeah, a number 3 in all the terms. Apart from them, we are having 1 n common in all the 3. So now take the common things outside. What are the common things we identify here? 2 into 3 into n. These 3 terms. Then write the uncommon terms. In first thing, we have all the things are common for all those things. So if you take anything common, all those things we have to replace by 1. So 1 plus. From here we took 2, 3 and n outside. What is the remaining? 2 and n. So 2 into n. Plus of, from the third term we took already 3 numbers. The remaining is 3 into n into n. So just write as a factor. So 2 3s are, how to write 2 3s are? 6n into 1 plus 2 into n is 2n plus 3 into n is 3n into n, 3n square. Okay, so we got the factor, or we factorize the given algebraic expression 6n plus 12n square plus 18n cube as 6n into 1 plus 2n plus 3n square. So if we are having single algebraic expression, we can't use the identity or anything else just by taking the common outside. So use the irreducible form. If we take the common outside, then the combined will give you the factor of this algebraic expression. Okay, so here we factorize this to example. Based on this, we have to factorize the other problems also. So now we will move to the fourth problem. Now the fourth problem, factorize using regrouping of terms. Factorize using regrouping of terms means we will be having 2 or more terms here. Okay, so by regrouping, now in the previous problem we have learned how to take the common outside from the each term. Using that knowledge we are going to solve this problem. Okay, so each and every problems are correlated with the next problem. Right? So we are going to regroup. Regroup means we are going to group the numbers as the thing has common, as the factors are common for the 2 or 3 terms. If the things or factors are common means we will take them outside and we can furtherly factorize them. Okay, that technique only we are going to use here. In the first problem, a cube minus ab into a minus b minus b cube. Here, by seeing simply, we are having some terms, 1, 2, 3 terms, but we can't take anything common from here, isn't it? So, what we are going to do? Furtherly, we are going to express this as a cube minus, if we multiply this, because this term is in the product form of products. So, if you multiply this, a square b, minus into minus will become, plus a b square minus b cube. Isn't it? Just first I remove the bracket. Whenever you are grouping the terms, first thing for factorization you have to remove the brackets, then you have to factorize as the terms. So first we removed it. Now we we are going to combine the terms or group the terms in that, like we should have a common factor in that. So how to group it? Just the first two, a cube minus a square b. If I group once, I can take a common. And the last two, a b square minus b cube means we will take b common. Yes? So you have to group the numbers. Four terms are there. You have to group the terms accordingly that you should get a common factor outside. Now, in the first term, what is the common? A square. A cube a square. From this I can take the term a square common. If I take a square common, here a cube. A cube means a into a. A square means this 2a will come outside. So remaining one a will be there. Minus a square fully a took common outside. So the a square will not be there, only b. Plus in the second term we can take b square b cube, which we can take common b square. So b square if I take common, the remaining is a minus b. Now again it is not in the form of factor. Factor means it should be the product of irreducible forms. It should be in the form of product. But see, a square a minus b plus of b square a minus b. So not yet factorized. What do you have to do? Now we are having two terms. See, in our we are having two terms. Observe these two terms. What is common in this two terms? Yeah, a minus b. So if you take a minus b common from these two terms, the remaining will be a square plus b square. A square plus b square. See, the given expression expressed here as the product of its factors. Okay, so we factorized the given algebraic expression and we got as a minus b into a square plus b square. Now let us see the second problem. Here we have to group accordingly so that I should get the factor of this expression. How to group this? See, I hope already p square is common, q square already it is in the format of grouping only. No need to rearrange it. In some problems, p square is there, the second term will not have p square. But third or fourth terms will have p square. Just we can rearrange the given expression and we can group that and we can find the factors. Okay, now how I am going to group this is 2a p square plus 3b p square. I am grouping this plus 3b q square plus 2a q square. Group this plus 4a pq plus 6b pq. Group this term. Okay. By grouping these terms, in the first two, I grouped accordingly, it will have some common factor. So what is the common factor in the first two terms? Is p square. 2, 3 different numbers. A, b, they are different variables. So what are the common variables here? P square. So if I take p square common, the remaining is 2a plus 3b. Plus, in the second term, what is common? Q square. We are having the variable q square is common. So if we take q square common, the remaining is 3b plus 2a. Plus, from here what can be taken common? 4, 6. What is the common factor for 4 and 6? What is the common factor? 2. Because 2 2s are 4, 2 3s are 6. So if I take 2 common and the number variable pq is also common. If you take this, the next one is 2a plus 3b. Isn't it? Now we are having 3 separate terms. But they are not the factors. Furtherly, we have to write in the product form of product. So observe these 3 terms. What is common in these 3 terms? Yeah, 2a plus 3b. Here this is the form of 3b plus 2a, but it can be rewritten as 2a plus 3b because both are having the same sign now. So we can consider as 2a plus 3b. So what is common in these 3 terms? 2a plus 3b. So if we take 2a plus 3b common, what are the remaining thing we are having? P square plus q square plus 2p cube. Yes. Now also we are having 2 terms. 2 See this p square q square plus 2pq. Whenever you are solving a problem in algebra or if you are seeing algebraic expression in any chapter, you have to be strong in identity. Okay, whether the identity is possible to apply there, surely you have to apply the identity and solve it. Okay, so by seeing the second term, do you guess anything in your mind? P square plus q square plus 2pq is, got it? Yeah, what is the formula? A plus b whole square or x plus y whole square, whatever it is. So it is in the form of a square plus b square plus 2 into a into b. So it can be rewritten as, how it can be written as? P square plus q square. Further it can be written as p square and q square. So we got the factors as 2a plus 3b into p square plus q square. So the factor of the given algebraic expression, nearly it has 6 terms. So the factor of this algebraic expression is reduced as 2a plus 3b into p square plus q square. Okay, yes. We'll see the next problem now. Now we are going to solve the problem number 5. Here also we are going to factorize the algebraic expression but using identity. Okay, have you remember all those identities in algebra? In previous 6.1 and 6.2 exercise, 6.2 exercise mainly we have solved using algebraic identities. 4 main identities I taught you. A plus b whole square. Have you remembered that? What is that? A plus b whole square is equal to a square plus b square plus 2ab. A minus b the whole square is equal to a square minus 2ab plus b square. And a square minus b square is equal to a plus b into a minus b. And the fourth identity, x plus a into x plus b is equal to x square plus a plus b into x plus ab. This 4 main identities I taught you for the previous exercise and we solved many exercises based on this. Today, here in this we are going to use the identity and we are going to factorize this. How to factorize this? A square plus 4ab plus b square. Okay, so now see how by seeing this, a square and b square is there. First, I am going to rewrite like this. A square 2 into 2ab plus b square. 2 into 2ab plus b square. Now, see here, actually this is 4b square. Okay, so a square plus 4ab plus 4b square. Now, so the last term can be written as 2b the whole square. See, a square 4ab can be written as 2 into 2ab. Okay, plus this term can be written as 2b the whole square. By saying this, you can identify a square 2ab plus b square. What is in the form? What is in the place of a? And what is in the place of b? 2b. So the expanded form of this identity only a square 4ab plus 4b square. Okay, now see the second subdivision, x square by 16 minus 2x plus 16. Here also it is hidden that it is in the form of a minus b whole square. But we have to, by seeing the question, we can't directly say this is the identity. We have to guess what is the identity used here. By first term, here it is a square number. The last term is also square number. In middle we are having in the form of 2ab. So you have to check like that which identity is appropriately used here. Okay, so how to rewrite this diagonal? X plus 4 the whole square minus 2ab, the last one 4 square, 4 is 16. So how 2ab will be 2x simply. So apply and see. If a I put for x by 4 and b I put for 4 and 4 will get cancelled, the term is 2x. So already it is in this form, that only we got a simplified form as 2x. So this machine can be expressed as a square minus 2ab plus b square. So in place of a we are having x by 4 plus in the place of b we are having 4 the whole square, that is minus now. So a minus b the whole square. Okay, so a square minus 2ab plus b square. But here they gave the reduced form. They simplified and gave the reduced form. From that we have to identify which identity is used. So we factorize using the identity here. So here mainly the a plus b and a minus b whole square identity only useful. So do that for the factorization. So based on the manner what we have the problem did today. Okay, we learned newly the factorization for algebraic expression. Okay, already we are familiar with the factorization of numbers, arithmetic numbers. Here we did the factorization of algebraic expressions, and we have learned how to write the given term in the irreducible form. From the irreducible form, how to find the factors and HCF. Also using the HCF, how to find the how to factorize the given expression, and by rearranging or regrouping the given expression, how to do the factorization. Finally, we did the factorization using the identity. Okay, so based on this manner, you have to solve the other problems also. You will get your assignment PDF based on the problems we have solved, same model problems. You have to work out all the assignment problems yourself and submit in the group. Okay children, thank you.